So last time we finished about B. We finished for P3, but I left some examples. I was talking about the exponent and like the exponent for integers. So I was talking about the exponent. So I was talking about the integer exponent. I saw the lecture last time about the integer exponent. I said it's like a product of identical numbers. For example, 5 times 5 times 5 times 5. This integer, this is integer, this is integer, and the answer I can make it as exponent 5 to the power 3. Now the quiz is next Tuesday on WebAssign, last 15 minutes of the class end. So another things, and I explained this as in general idea, in general for the exponential notation, I said a to the n is equal a times a times a times n times a. This is like n factor. And I gave like 2 examples. I said I gave last time 2 examples. I said minus 2 to the power 4 here is not equal minus 2 everything to the power 4. Why? Because here I apply the exponent only for the 2 here, but here I apply the exponent the 4 for everything with a minus. So here this is equal minus 2 times 2 times 2 times 2. And this is not equal to minus 2 times minus 2 times minus 2 times minus 2. Okay? Because here the answer is negative, here the answer is positive. This will give me here minus 16, but here they give me only 16 positive. And this is not equal to each other. Minus 16 is not equal to 16. Okay? Also, I was talking about the 0 and negative exponents. Also, last time I gave definition of 0 and the negative exponent. So I said any real numbers a raised to the power 0 is equal. What's the answer? Any real numbers raised to 0 is 1, always 1. 16 to the power 0 is 1. 100 to the power 0 is 1. 2000 to the power 0 is always 1. And about the negative exponent, I said a to the minus n, but then for that n is positive, natural number. It's a natural number. This is equal 1 over a to the n. And here belongs to natural number. The natural number is 1, 2, 3, 4, 5, 6, 7 to infinity. Okay. Also, I gave last time the rules of exponent. I said about the rules of exponent. I said like a to the m times a to the n we do the sum of the exponent because the base are equal. Here the base is a, the exponent is n, so it gives me n plus n. Second rule, I said a to the m divide by a to the n because we have the same exponent, is same base. Exponent is different. This is equal a or to the m minus n. We do subtract for both exponents. Number 3, I said if I have a raised to the power n, all of these raised to the power n equal a and n. We multiply both exponents. And I gave example last time. Any question about these? Okay. Also, I gave rule number 4. I said a, b, all of them to raise to the power n. I can distribute the exponent for both variables inside the parentheses. So this is equal a to the n times b to the n. Number 5, a over b, all of these to the n. I can again distribute the exponent inside the parentheses equal a to the n over b to the n. Number 6, I said a over b, all of these raised to the power minus n. I flip inside a over b, all of these, I mean b over a. Sorry. So this is equal b over a to the power n. Number 7, last one, if I have fraction a to the power minus n over b to the power minus m, is equal b to the n over a to the n. And I gave example. And I end the class. Any question about the rules from last time? Okay. I end the class by example for simplifying expression. Again, the example as first one I did in the class last time, so I'll start doing for the second one. Second one says simplify this expression: x over y, all of this raised to the power 3 times y squared times x over z, all of these raised to the power 2. How can I start thinking for this? How can I simplify this expression?
You can use the distributive property.
Distributive property. So I start from the first term, right? And then I do the second term, right?
Yeah.
So, okay. So what I have to do? The first term?
So you
Equal
do
what?
X to the third,
To the,
because you do like
okay.
and
y to the
third.
third.
Yeah.
Yeah. Okay. So for the second one, what do I do with the second one? Y square x over z. Everything to the power 2. What I have to do? What does that equal?
Y to the 4.
Y to the 4
times x to the second.
to the 2.
And then z to the 2.
to the 2. I can simplify this more. What is that equal? If I want to raise this one up, move this variable to the up, what I have to do? Times x squared times what?
B.
This to the negative 2.
Oh,
Exactly. What about this, the first one here? If I go back to the first one here.
x times
Equal.
to the third times y to the negative 3.
Exactly. So now I simplify the first term, simplifying the second term. Now I multiply this one by this one by this one. That means multiplying this one by this one. So I'll go here, x to the third times y to the minus 3 times y to the 4 times x raised to the power 2 times z raised to the power minus 2. What does that equal? What does that equal?
X to the
Yes.
fifth
X to the fifth.
times
Okay.
Times y.
To the y to the 1
Yeah,
or
to the
y.
1, yeah.
Okay. Times what?
Times
This one.
times c, yeah, times c.
Z to the minus
Negative 2.
2. So here x and x, both of them have the same base, but they have different exponents, 3 and 2. So we're doing summation. 2 plus 3. It's 5. For the y and y, here we have the same base, y and y, but different exponents, minus 3 and 4. We do summation between 4 and minus 3. 4 minus 3 is 1. Here 1, or I can like remove it. And here the remaining is z to the power minus 2. So I don't have any z during this so I keep it alone without anything. And I can this is equal again, x to the 5 times y over what? This is moving down, z to the power 2, positive. Any question?
Wait, so it's a fraction because you had to flip the exponent, right?
Yes, because it's negative. Now when I slip it down, I'll move it down, become like positive exponent. See, the 2 is positive, but up is negative. Any questions? Okay, let's do another example. So this is here equal x to the 5 times y over z to the 2. I do another example inside this. So this paper again. So see, question is the same thing, simplifying expression. I have y over 3z squared. All of this to the power minus 2. What is that equal?
Doesn't it equal 3z squared over y? Parentheses.
3z squared over y.
Parentheses.
Yeah, okay. You flip everything. Exactly. So 3z squared over y, parentheses what?
2.
2, exactly. Nice. Then, what does that equal?
3z to the 4th,
You distribute the 2 inside, right?
to the 4th,
So 3 to the 3 square times z to the 4th over what?
y squared,
Y to the square, exactly. And this is equal 9 times z to the 4th over y square. If I want to simplify it more and more, equal 9 times z to the 4th times y to the minus 2. Any question? Okay.
So wait, is the answer, is it that the last thing you wrote?
Yes. You can like keep the answer looking like this or like this.
Okay, so you accept both
Okay.
answers.
Yes. Both of them are right. Any question? Here. So can I move now to the next slide? Okay, I give you another example. So example says again 6s times p to the power minus 4 2s to the power minus 2 t square. What does that equal? How can I simplify it? Who will help? How can I simplify this one? Michelle, can you do it?
I would say we can start off by maybe crossing out the common factor between 6 and 2, which would be
6
2.
and 2,
Yeah.
they will give me what? 6 and 2, what they
3.
give me? 3, exactly. So here I can simplify the 6 and 2 by 3. The numbers, I simplified by 3. Now the s and t and t. So I keep everything again, s times t to the power minus 4 times. I raise this up, I move it up. How can I move it up? S to the power minus 2. What I have to do? S to the what?
Flip it to 2,
To the 2, positive 2. The t,
negative
the
2.
2, negative 2. Now it's simple, easy. Again, we have s and s, both of them the same base. Here we have 1, okay? So what we have to do, we multiply it by s to the power what?
To the third.
To the 3. Why? Because 1 plus 2. And again, for the t, here minus 4 minus 2 is minus 6. I can change this one as looking like 3s to the 3 to the power 3 over t to the 6. I can move the t over minus negative power to the down. I move it down and I keep it positive. Change it to the positive. another example. Any question for this one? Okay.
Is there a reason why you put the
Why
T
is-
on the bottom?
Yes, why about the T in the bottom? Okay. So again, look to the T. What is the power for the T? What's the sign of the bar? What's the sign of the exponent for the T? What is the sign here?
-6.
Negative 6. I can move it down and I change the negative to the positive. Okay, so I can move it down, the T here to the negative. I change it to the positive, T to the power 6 positive. That's why I brought it down.
All right, got it.
Make sense? Okay. Okay, another example is y over 3z square, everything to the power -2. Again, the same idea. Who will do it? Kimberly, you want to do it?
Sure.
Yes.
Okay, so we're simplifying it, right?
Yeah, simplifying. How you simplify it?
Okay, so y over,
Hold
well,
on.
y
Do you see?
squared.
Hold on. Do you see the negative? This one?
Two.
-2.
Flip.
You see the negative?
So y negative squared.
No, I mean when I see negative, we flip everything inside the parentheses.
Okay.
So what's the answer? Is 3 what?
So
Is it square over
squared
what?
over y
Everything to the what?
to the negative,
To the positive.
to the positive.
Yeah, because I flip everything, I change the negative to the positive.
Mm-hmm.
Now I distribute the 2 inside. What does that give me?
So 9,
9
z
what?
4
To the square multiple 2. Everything to the power 2. Over what?
over y squared.
Square. And this is equal 9 times z to the what? That's the exponent for the z.
To the 4th power.
4 power over y square. Okay, any question for this one? And this is the simplest one. I can simplify it more. I change the power for here from positive to negative. This is equal 9 times z to the 4 times again y to the -2. Both of the answers here, if you keep the answer like this or you keep it like this, both of them right. Okay, let's now, any question before you go to the next section?
I have a quick question.
Yes.
When you were simplifying, wouldn't the 9z square, wouldn't that be a z to the 8th power? Or I think I missed that step. Can you just redo that?
Which one? In the second example or the first example?
Or on the second, like the third step there. Can you redo that?
Okay. So for the second example, here we have negative exponent, -2. So when I see negative, this means we have to flip inside the parentheses, everything inside the parentheses. If flip everything inside the parentheses, they give me 3z squared over y. And now we change the sign for the exponent from negative to positive. This is the first thing. Now we distribute everything by the power 2. So the 3 raised to the power 2 is giving me 9. Let's square everything raised to the power 2. They give me this to the 4th. Y raised to the power 2, they give me y squared. And this is, I can here, this give me 9 times z to the 4th over y squared. Now I can flip this one, I can move this one the y squared to the up by changing the sign of the power of the y squared. So it's positive, I change it to the negative. So the answer is 9 times z to the power 4 times y to the power minus 2. I hope I answered your question.
Yes, you did. Thank you. I actually made a mistake when I was writing the problem on my notes. So it was a
Okay.
mistake on my end. But I saw
Okay.
it when you started working on it. So thank you.
No problem. Okay. Okay, let's go now to the new section. It's called radicals. It is the new section is the P.4. Radicals. So what's the radicals? So anything of the form square root or anything, any root, nth root or square root. I will start from like simplest things, square root of A. They give me answer B. What does that mean in general? In general, this is mean if I square the B, they give me A. This means B squared, B to the power 2, they give me A. Does that because it's square root mean B is positive or 0. This means B greater or equal 0. This means B is positive or 0. And at the same time, A must be positive or 0. I give you example like square root of 9. What's the answer?
3.
3. What does that mean in general? This means like if I raise up 3 to this power 2, they give me inside under the radical. Mean like 3 to the power 2, they give me exactly under the radical 9. And at the same time, B9, the number 9, is positive numbers, is greater or equal 0. And at the same time, 3 is positive numbers. So in general, I give you the idea in general. The definition of nth root. So that means square root, not square, the nth root of A is equal B. Anyone has a question?
Yeah, I wanted to ask, can you explain the last part which it did of the 9,
Okay, this
Eight.
one.
then 0,
Okay.
and
Yeah. So for square root, anything for square root must be inside the radical, under the radical, positive. Must be this part positive for any square root. Square root of 16, square root of 17, square root of 18. We don't say square root of minus 16. This is wrong, right? This is not in real numbers. This is in different things, differences. Or we don't say, for example, in real numbers, minus 17. This is wrong. Okay, makes sense. So here I mean anything under the square root must be positive. I mean number 9, it means is positive number, and the answer must be positive for real numbers. Okay, so the answer for the radical must be positive, and under the radical must be positive for square root. So for the nth root in general equal B, this means B to the n must be equal A. And here, if n is even, then a must be positive. So I make it in general. If the root here even number, must inside the radical positive. What's the even numbers? Who knows the even numbers?
2, 4, 6.
2, 4, 6, 8, 10, 12. All of these are even numbers. So if the nth, if the n is even number, 2, 4, 6, 10, 12, whatever, under the radical must be positive. I mean, for that, what's the square root of 81?
9.
9. Look, 81 is positive. Why? Because the 2 here is even number. What is the third root of -8? Look, here negative numbers. Why? Because this is odd number. Odd number, I can put here positive or negative, doesn't matter. But for even number, must be positive. The answer is -2. And also look to the answer is negative. What about the fourth root for -8? What's the answer? What's the fourth root of -8? Do you have answer?
I was gonna say 0.2, but it's not. It'll be like a decimal, right?
It will be no answer.
No? Okay.
Why? So the answer is undefined. Why? Because we have here even number. Look to the 4. The 4 is even. So here under the radical must be positive, but the -8 is negative number. Because -8 is negative number. And number 4, the power is 4, the root of 4 is even number. Make sense? Any question?
So what about if the A was a positive number?
It has an answer. It will be like decimal, 0 point something,
So it's
or
still
like
fine?
no. If it's positive, the fourth root of 8, it has answer, but we will use like the calculator for this one. Okay, we don't need it. We don't have to use the calculator for this class.
Okay. So when there's a negative number, right, inside the root, what it's squared to has to be an odd number?
No, so the even number, I will write it down again. It is like 2, like square, 4, 6, 8, 10, 12, and whatever. And the odd numbers, and for the even numbers, must under the radical positive. Look here, square root must be positive. For the odd, doesn't matter, it's negative or positive. I don't care. Okay. Okay. So I can go to the next slide. So properties, we have properties for the radicals. What is the property? Here. First things, if I have two numbers, A and B, both of them are in real numbers. This is mean here again, N. This symbol means N. Both of A and B in R. First things I have to know, the square root of, like the nth root in general of A times B, I can write it as the nth root of A times the nth root of B. I give you example. So example, third root of minus 27 times 64. What's this equal? What's the answer? I can separate it, everything inside to the two radicals. Equal what? What's the answer here? Third root of what? For the first part, this is A
-9.
and this is B. What is A here?
No.
-9.
A times B. Well, from where you get the -9? -27 times 64. So what's it's -27? Do you mean, right? Not 9. And this
Wait,
is
I have a
B,
question, my bad. Can we just
64.
simplify?
Now you can answer. What's the third root of -27?
-3.
-3. And what is the third root of 64?
8.
It's 4. Okay.
4.
So the answer is -12. So again, if I have nth root of two numbers, the first number times the second number, this is equal the nth root of the first number times the nth root of the second number. For the example, the first number is -27, second number is 64. Is equal the third root of the first number is -27 times the third root of the second number, 64. Here again, number 3 is odd, so inside doesn't matter is positive or negative. Okay. Any question?
Can you do another similar problem?
Okay. So example, another example. What is the square root of 4 times 16? Instead of multiplying 4 times 16 and I get the answer and then I found that second root or the square root of 4 times 16 and it will be like big number and I don't have calculator, I can use this idea by separating everything inside to the two radicals. Radical times radical. The first number is, what is that? Is 4. Second number is 16. Okay. What is the square root of 4?
2.
2. And square root of 16? 4. The answer is 8.
Wait,
Easy.
you still can break down the 4 or?
The 4?
No, I'm talking about like
No.
16. What's it called for 16? Well,
Just you break, I mean, like you break down the number inside only. This is A, this is B. This is the number A, this is B. This
yeah,
is A.
I'm saying you could still break down the 4.
No, we don't have it because I know the square root of 4.
No, I'm talking about like the square root of 16. You get 4, then you could break that down to even another 2.
If I break it down to another 2, I like 2 times 2 times 2. All of this, they give me the same answer, 8. This is the 2 here, and this is for 2 times 2 for the 4. Doesn't matter if I break it down or keep it the same thing.
On the first
No, but I
example,
answered your
when you
question.
said it's an odd number, you said it's supposed to be a negative. How did 64 become 4?
64 has become 4 because I know the third root of 64 is 4, positive 4. And like for the odd radicals, if inside is positive, the answer is positive. If but for the negative inside, they give me negative answer. Look here, the third root of that minus 27, they give me minus 3, negative answer. For the third root of 64, the positive inside, they give me positive answer, 4. Minus 3 times 4 is minus 12. I answer your question?
I'm sorry, so just to have an understanding, when the number on top of the square root symbol is not 2, if it's like whatever that number is, I have to find the number that, like, so for example, the 64, pretty much 4 times 4 times 4. I mean, so 4 times 4 and then 16 times 4 will give me 64, like that.
Yes, exactly. Yeah, you think it like that, like I mean, like 4 is being, why the answer for, like I said before, like going back to the last slide here. Square root of A equal B means B square equal A. If I square this answer, they give me A. That's why the answer for square root of A is B.
Okay, cool.
Okay. Now, why the answer is 4? Why the answer is 4? Because I know 4 to the power 3, this one, they give 64. That's why the answer is 4.
Okay, cool. Because
Same things here. Why the answer is minus 3? Because minus 3 to the power 3 is minus 27. Here means why the answer is B. Means if I square the B, they give me inside the radical A. Going back again, why the answer is 4? Because 4 to the power 3, they give me 64. So in general, I'm looking for a number. If I multiply 3 times, they give me 64. I'm looking for numbers here. If I multiply the numbers 3 times, they give me minus 27. Same things here. I'm looking for numbers. If I multiply 2 times, because the power here, the root is 2 for 2. 2 times, they give me 4. It's 2. I'm looking for numbers here for 16. If I multiply 2 times, they give me 4. They give me I'm looking for numbers. If I multiply 2 times, they give me 16 is 4. This means here the square root of 4 is 2. Square root of 16 is 4. Square root of 4 is 2. Square root of 16 is 4. 2 times 4 is 8. Make sense? I think I understand your idea. Like you asked me why the third root of minus 27 is minus 3. I think I answered the question. Because minus 3 to the power 3 is giving me minus 27. You asked me why the third root of 64 they give me 4. Because 4 to the power 3 they give me 64. Okay? Make sense?
Yes.
Okay, the second one is the same idea, a over b to the power nth root of a over b. I can split it to the two radicals, the nth root of a over the nth root of b. Same idea exactly. Example. So the example is the square root of 6, I mean like 16 over 4. So I split the radical by using this formula to two pieces. First one, square root of 16 over 60 square root of 4. So I ask myself which I wanna number such that if I multiply this number, they give me 16. 4.
Over 2.
4. And square root of 4, I'm looking for number. If I multiply this number, they give me 4.
2.
So the answer 4 over 2. And it's equal what?
2.
2, exactly. Why? I simplify it by dividing both sides by 2. 2 over 1. And this is equal to. Makes sense? Any question? Third one.
Can you just repeat like the process you did for the last one?
Okay. So square root of 16 over 4, I can split it by using this formula. Square root of 16 over square root of 4. Because the first number is 16. This is my A. And this is my B. Look, hey, this is A, B. A over B, the nth root of A over the nth root of B. Square root of 16 over 4 is square root of 16 over 16 square root of 4. Now, I need number. If I raise it to the power 2, they give me 16. What's the number? It's 4. Because 4 to the power 2 to this power, they give me 16. So 4. Square root of 16 is 4. Square root of 4 is 2. Now I simplify it. I divide this by 2. This will give me 1. This give me 2, and this 2 over 1 is 2. Yes, Steph.
Okay, so let's assume one of the numbers doesn't have a perfect cube or a perfect square. Like, do we just leave it in the what's it called?
Exactly. If we don't have like perfect square, like for example, square root of 17, I leave it square root of 17.
Okay, thank you.
Yeah. I hope I answered the question.
Wait, so the 4 over 2, right?
Yeah.
How do you get to the, for it being 2?
How do I get 2? Okay. So 4 over 2, I simplify it by dividing that 2 by 2. What's the answer? Is 1. 4 dividing by 2, because I know 2 times 2 is 4. Or in other words, the 4 I know it's equal here. 4 over 2 is exactly like I know 2 times 2, right? Over 2. So I cancel 2 with one of them, and they give me 2 over 1. And this is actually equal to.
So you're dividing the number with the number that it's
I cancel.
So
Cancel 2 with 2.
you're dividing the 4 with the exponent number, right? So if the exponent number wasn't 2, let's say it was 3, you would have done like 4 divided by 3.
If 4 over 3, I can't dividing anything. There is no common factor between each other. If like for example 4 over 3, I can't, this is equal 2 times 2 over 3. I can't cancel any one of each other. No common factor.
He's
So I
not.
keep it like this.
He's not dividing the number by the 2 that's on top of the square root. He's just simplifying the 4 over 2.
Yeah, it's in the simple formula 4 over 3. It's already simple.
Okay.
Steph, what's your question?
Nah, it's okay. I was just gonna explain it better.
What's that?
Wait, can you repeat that?
4 over 2, I can like the 4, it's equal 2 times 2, and the 2 I keep it the same thing. So I can cancel like I learned before in the last section. If I have something like that, if I have like something like that, A times C over B times C, I can cancel the C by the C and they give me A over B. Same things here. The 4 is equal 2 times 2 over 2 times 1 or times 1. So I can cancel the 2 with the 2 and they give me 2 over 1. And this is actually equal to 2. Because anything over 1 is, they give me the same things as in numerator. About 4 over 3 is 2 times 2 times. So it's simple. I keep it the same thing, 4 over 3. Makes sense? Any question? Steve? Okay, let's go to the next slide. M times N of A. So I have root over root. I can multiply the both of the nth of each root. So this is mean like M times N of root A. Example. Third root of second root of What is equal? The answer. What's the answer here? 3 times 2, 6. So it's equal the 6th root of 4. Make sense? Any question? The last
So you just leave it just like that?
Yeah, leave it like that.
All right.
Fourth one, if I have the nth root of a to the n, this is equal a, or the absolute value for a. This is a if n is odd. Here, if n is even. What is the absolute value for a? What does that mean?
It makes it positive.
Make everything inside positive. Like, I give you hints. What is the absolute value for 3? It's 3. What's the absolute value for minus 9? Is
9.
make 9 positive. What's the absolute value for minus 7?
7.
Is 7. So this is mean make everything inside positive. If you wanna know what the formula for this, it's not required, but I give you. This is mean if the number is positive inside, keep it positive. If the number is negative inside, multiply by negative. Then when we multiply by negative, it's become positive. So again, if n is even, I said what's the even numbers? Going back here, this is the even numbers. 2, 4, 6, 8, 10, 12. And the odd numbers 1, 3, 5, 7, 9, and all of them. If n here is odd, keep it like a. Whatever a is positive or negative, doesn't matter. But if n is even, must be the answer be even. Example. What is the 9th root of minus 7 to the power 9? What is 16 root of minus 9 to the 16? Fourth root of 8. Second root of 25. Third root of minus 27. What's the answer for the first one?
Is it going to be -7?
Negative 7. Why? Can you explain why?
The 9s are going to cross out.
Okay.
And
Yeah. Now 9 is odd or even?
it's odd.
Odd. So keep everything inside like exactly like inside. The answer exactly like this one.
Oh,
Minus
okay.
7.
Okay.
Okay.
Yeah, I get it. Now.
Okay. Second one. Who will answer the second one? 16.
It's going to
Even
be
or odd?
odd.
16 is even.
Oh, Steven is my fault. Even. Yeah,
So what's the answer?
isn't it still going to be -9?
It will be the absolute value for -9. Look into this one, and is even. This means the absolute value for inside.
Oh, because I
Okay.
thought that meant if A was like
To be
positive.
9. Positive
Oh.
9.
Okay.
Third one. Who will do the third one?
5.
It's 5. Why? Because we have here square, and it would be like, if I want to change this one, hold on. This is 5 exactly. But how you think about this one? How we can think about this one?
What number when you, what was it like, you
This
multiply?
is exactly look like this. Look. Here is even. And it's even. They give me the absolute value for 5. And this is what? 5. Who will do the last one?
3.
It is, what's the number here?
It is negative 3.
The number is odd.
-3.
So odd, keep whatever it is here, keep it. So it'd be like -3. So just you have to check the root is even or odd. If it's odd, keep whatever inside, put it like the same. If it's even, change the sign to positive and keep it the same. Take the absolute value. I mean, this is even. Take the absolute value. This is odd. You don't have to take the absolute value. Any question? So first things you have to check even or odd. Then you solve the question. Let's go to next slide. Here example. Simplifying. Yeah. How you think about this one? Who will do this question?
Professor, would you separate the like the x to the third, square root it
Nice.
separately from the
Nice.
x?
Perfect. This is what I'm gonna do. So I have to separate everything inside.
X.
By using the property. Now what does that give me? What's the answer? How you think about this one?
Would it be x to the 27th power?
X to the 27.
Uh-huh.
x. But here, look, it's 3 and 3.
Is it just x times
Give
radical?
me x times what? Look here, 3 and 3. Like using the previous slide. If the same things, n and n, I have to check if it's odd or even. If it's odd, the answer will be like the same side. If it's even, the absolute value.
If it's odd,
Here,
the answer will be what?
it's odd, so I keep it the same thing. Will be x. Keep it the same, exactly x.
Wait, I
And here,
have a question. My bad. Wait,
multiply by x.
why didn't the 3 carry to the other x?
What's your question?
Why didn't the 3 carry to the other x, like the cube on the whole thing equation?
How? Like everything to the cube?
Like you see how you got cube x3 times just what's the square root of x? I was thinking since they was all raised to the power of like 3.
Oh, hold on.
Like,
Here is not square root. I'm
yeah.
sorry, not square root.
Okay.
Cube. Sorry, not square root. I'm so sorry. This is 3. Cube. It's the cube. Everything cube here. Not the square root. So again, by using the formula before, here, like before, it's x. And this is, I keep it the same exactly. The cube root of x. The 3 is odd number. This means everything inside. Do you need another question? I give you another example. How you can simplify something like that? How?
It's 4 radical, it's x times,
It is the fourth root of x to the 4
yeah,
times what?
times 4
Fourth root
to
to the x,
s.
right? Okay.
And then it's x times,
This is what is equal?
even.
The 4 is even or odd? Even. So that means
X,
the absolute value of what? For this guy.
x.
Times, this goes down.
The first one, the root is odd. Why don't we put negative for that?
Odd. So for odd, I keep it the same things, not negative. I keep it exactly the same things. I keep it inside x. If it's x, I keep it x. If it's negative x, I keep it negative x. But for this one, I keep it exactly absolute value for what's inside. Absolute value for inside. Here I keep it the same thing, whatever it is, negative or positive. I don't care.
Okay, so question. Would it be wrong, like if it's like when we have a even number as like the cube or so, when we write our final answer, it has to be an absolute value, even though the absolute value would still just be x? Would we
For
still
even numbers,
have to write
for
it?
even,
Yeah, for if
for
it's
even radicals must be absolute value. Must be absolute value.
okay.
Now let's go to something new. It's called rational exponent. We finished the radical exponent. Now rational exponent. So what's the meaning of rational exponent? I know the rational numbers, it looks like R equal M over N, such that M and N are integer numbers and N not equal 0. M and N integers and N not equal 0. This is the definition of rational number. Now, rational exponent, anything look like A to the M over M, such that M and N are integers. And this is, I can define it as the nth root of A to the M. So this is the definition. Or other word, A M over N equal the nth root of A, everything to the N. Okay. Again, if M and N are integers, this mean and N is greater than 0. Like I said before, M and N are integers. And N here must be not equal 0. Like here, like before. Or because it's exponent, I want to specify it by N is greater than 0. I give example explain what I said. What is the 4 raised to the power 1 over 2? 1/2. So is that equal?
2?
2. How do you think about this?
Half of, I mean,
Like what is the mean of half? 4 to the what?
2.
The 1 here, the 1, it's M. And the 2 is N. Again, 1 is M, and 2 is N. The 4 is A, the letter A. I do the same idea like here. So 4 to the power 1 of the square root of the root of 2. Explain more. Here's the 2 goes here. And the 1
Is
here.
necessary putting the 1
The 1.
on top of the 4?
Again?
I'm saying, is it necessary putting the
No,
1?
it's not necessary.
Okay.
It's not necessary, no. So I can keep like this. The square root of 4 without the 1. This is equal 2. Another example, 135. I mean 125. All of this to the power minus third. Before I start minus third, let me keep it positive third. What is that equal? Again, this is 125 to the power 1 of the root of the third root. And some of you said 3. This is true. Why? Because no, it's not 3. Sorry.
5.
It's 5. Why? Because 5 times 5 times 5 is 125. So again, look, the 1 comes inside and the 3 comes outside. The answer is 5. Another one, if the question is 125 raised to the power minus 1/3, what's the answer? Similar to this exactly, but the minus means we flip this 125 over 1 actually is over 1. This is over 1. So become 1 over something. Become 1 over 125 to the power 1/3. And 125 to the power 1/3, I solve it here in the second one, in this one. This one, in the second one. The equal is 5. So the answer is 1 over 5. Any question? Anyone has a question? Okay. So I'm going to give another example. Okay, simplifying. So the question is example. Simplifying. By writing the radicals as exponent. So how can I write this one, the radicals as exponent?
Okay. So I'm thinking it's gonna be x.
The power what?
Well, isn't the 3 is gonna be negative, right?
No, I will first keep it the same thing. Like I will not raise it up. I'm not gonna like move the radicals to the numerator. I want to keep everything the same, like keep it in down. I don't want to change it to sign.
Oh, it's gonna be 1 over x.
1 over what? X to the raised to the power what? No, it's not x. Here we have the third root of x to the 4th. Third root of x to the 4th.
12.
So x to the 3 over 4.
Oh.
Okay. Again. A over n. This is exactly like the square root of n, a to the n. Here we have the radical. We want to change to the rational. Something look like this. So 1 over x. Here the root is 3. And the exponent for x is 4. Okay. Hold on, here. Something wrong here. So this is equal x to the what?
4 over 3.
Over 3. Yes, 4 over 3 is equal 1 over x 4 over 3. So the radical, the root, the power for the root is in the denominator, and the power for the x for the variable is in the numerator. Okay, how can I just move it up? What I have to do? Now I move this one up. What I have to do? Negative. I change it to the negative exponent. 4 over 3. That's it. Any question for this one? Another one. So the question is the same thing, simplify it. What's the answer I needed in rational form, like this? How can I solve this one? How can I think for this one? How? So first things we multiply the numbers.
So that'll be 6.
6
A
times
square root of x squared
times, right? Then we need to simplify it more. 6 times, what is that equal? X to the what?
Times x.
X to the what? What's the power?
X to the 4.
What's the power for this one only?
1.
Oh, it's 1.
Over what? 1 over 2. Because here we have 2. Times.
Where do you get 2 from?
Yeah, where the 2 come out of nowhere?
It's
The
because the
2 is
thing.
the square root. Okay, again. Let me do it again.
You mean just because it's a general square root, it has a 2 there?
Yes. So in general, the square root is written like this, or it's written like this. Both of them are the same. Again, 2 times 3 is 6 times the square root of x times third root of x. Here we have 3. Here it's hidden, but actually this is 2. Here is 2. So what's that equal? So 6 goes down. This one is x to to the power what?
To the second power.
1 over
2.
2 times. This is what's equal. X plus what?
Over
X
One,
over
two, 1 over 3.
1 over 3. Why? Because x has 1 here. X has raised to the power 1. Okay. So x and x are the same base. So we can combine this and this one. How? By adding the exponent by section B2. Right? Equal x times x 1 over 2 plus 1 over 3. And how we solve this one? By cross multiplying. First section, the second section in the box. 1 over 2 plus 1 over 3. Multiply this one by this one, this by this one, this one by this one. 3 times 2 over, no, I mean 2 plus 3. 2 plus 3 over 6 times 6 times 3. 5 over 6. So the answer here is 6 times x to the 5 over 6. Any question?
And we could have also left it as the 6 times x with the half plus 1/3.
You can lift it like this, but the question is simplifying. We need it in the simple form.
So to the most simplest form.
Yeah, most simple form. So again, let me explain things. The square root of a is the same as 2a, and it's equal a 1 over 2. Why? Because this is 1 here. Here is 1. Okay, any questions so far? So I'll stop the lecture until here. Don't forget, next week we have a quiz. Quiz 1. Next class. Tuesday. 4. B1 and B2. 2. Homework. Question for 1 and homework. Number 2. Any question? Yes, Chris.
So I have a question about the homework.
For which question? Yeah, which question?
It's just a general question on. It's about when you have you're adding two fractions and then you're dividing them. There's a question like that in the homework, and I was confused about how to proceed with that.
Like, can you give me the question?
Okay, give me 1 second. So, for instance, the question is 2 over 5 plus 1 over 2 over 1 over 10 plus 4 over 10.
All of them over?
1/10 plus 4/10.
1/10 plus 4/10.
I mean 4/20, sorry.
4/10, okay.
20, but you could do it like that.
So for a question like this, start by simplifying this. Hold on. We'll give you the idea how we can start thinking for this question.
All right, so you have to, you see how you said you have to find it for the first part. So you're gonna get 4/10 plus
Okay, perfect.
5/10.
So what about if you think about this question like that? 2/5 plus 1/2. All of this divided by 1/10 plus 4/10. So for this question, look, become more simple. This question here, I change it to different form, look like this. Now I need here one fraction. I simplify this one to one fraction. Simplify the second one to one fraction. Then I divide both of them. Okay, let me simplify this one. 2/5 plus 1/2. I need the answer just for one fraction, like that. So I can do cross multiply. 2 times 2, 4. 1 plus 1 times 5, 5. 5 times 2 is 10. So the answer is 9/10. This is the first part. For the second part, the same idea. I do it here. 1/10 plus 4/10. And this is equal cross multiply. Or we don't have to do cross multiply. The denominator are equal. Like I said before, if A/C plus B/C, the denominator are equal, this means A plus B/C. Same things here. Denominator is 10. 4 plus 1 is 5. So we have 4/10. Here we have 9/10. Now we will divide this one by this one. So here the last in things, 9/10 divided by 5/10. I said for dividing, we flip the second part. We flip this one, okay? And we change the divide to multiplication by going back to the proverbs in section 2. So this is equal to 9/10 times, we flip this one to the 10/5. We can simplify it. 10 with 10 is equal to 9/5. This is the final answer. Any question?
Thank you for explaining it.